Greetings, this is Chemistry with Nav. In this video we're going to take a look at equilibrium concentrations. Now, calculating equilibrium concentrations can seem quite daunting, but if you keep one simple idea at the forefront of your mind when doing them, then actually it's quite straightforward. And that is just simply let the change in the known substance be a multiple of x, i.e. x or 2x or 3x and so on. So let's look at that in practice. So here's a question. 0.1 moles of dichromate 6 ions and 0.1 moles of water are mixed in a non-aqueous solvent and allowed to reach equilibrium at a fixed temperature. At equilibrium, there were 0.03 moles of the dichromate ions. If the total volume of the solution was 100 cm cubed, find Kc. So there's two major steps here, and also don't forget, in an exam question this would be structured for you, so this would be going part by part, and I've lumped all of the question together here. So the major issue is writing in the concentrations, or the moles in this case. So we need to know the initial moles, and we need to know the equilibrium moles. And the initial moles are given as 0.1 for both of the reactants. And because it's an equilibrium and we're starting just with reactants, we assume from the question that the two products are 0 because they're not there at the beginning. And then the only thing that we're told is that at equilibrium there's 0.03 of the dichromate. So in fact we don't know any of those three. So that's what I mean by the known substance. So the only known substance here is the dichromate ions. Now, because there's a 1 in front of the dichromate in the equation, there's the balanced equation, because there's a 1 in front of it, I'm going to allow that change to be minus x. In other words, 0.100 minus x is equal to 0.03. That means that 0.1 minus 0.03 equals x, which is 0.07. Okay, and I can also say then that because there is a one-to-one relationship between the dichromate and the water, there's a 1 there and a 1 there, that this will also be minus x. That means this will also equal 0.03. But because there is a 1-to-2 relationship between the dichromate and actually each of the products, that means that for every 1 dichromate that I use, I produce 2 CrO4 minuses. That means that I'm going to increase by 2x. And if x is 0.04, 2x is 0.07, 2x is 0.14, we'll get there in the end, if I write the right thing down. And then we have the same with the H plus ions, because 1 dichromate ends up making 2 H plus, so that's plus 2x, and that's also 0.14 moles at equilibrium. So that's the first part done, and we now have to look at working out Kc. So in order to do that, I would need an expression for Kc, and because the C in Kc stands for concentration, we are looking at the products all over the reactants. Now the squares in the top line are because the stoichiometric numbers, the big numbers in front, are 2 for each of those two products. But we have the moles, and we're told in the question that the total volume was 100 cm cubed. So that means we can substitute in. So for the products, I have 0.14 over 0.1 squared times by the same thing. And for the reactants, it is 0.03 over the 0.1. The 0.1 is just the 100 cm cubed expressed as decimeters cubed. And if you divide anything by 0.1, you are multiplying by 10. So a further simplification would be 1.4 to the power of 4 over 0.3 squared. And if we calculate that, that ends up as 3.842 over 0.09, which is 42.68, but we report this to three significant figures, so 42.7. Now in terms of units, we are looking at concentration squared, concentration to the 4 on the top, mol dm minus 3 to the 4, and concentration squared on the bottom. So the bottom completely cancels, and the units are just going to be concentration squared. So that's mol squared dm minus 6.